Hello. So this is one of the doubts that came across by one of the AIHL students. So the student is asking about this that if m is equal to this, find the eigenvalues of m. Okay, so for this, what we need is the characteristic equation. That is, the determinant of m minus lambda I should be equal to 0. See, this is what we use generally to find the eigenvalues. Okay, so for this, what do we do? M minus lambda I. So it'll be what? Minus 4, 2, minus 3, 3 minus lambda times 1001 should be equal to 0. But please do not miss out on the determinant. Is the determinant of the whole thing that will be 0. Okay. So that gives me minus 4 minus lambda, minus 4 minus lambda, 2 minus 3, and over here it will be 3 minus lambda. This whole determinant will be 0. So what does this give us? So I can just cross multiply. So that will be minus 4 minus lambda. This is how we solve the determinant, right? 3 minus lambda plus 6 will be 0. So that gives us, let's simplify quickly. So it will be minus 12 plus 4 lambda minus 3 lambda plus lambda square plus 6 is 0. So it will be lambda square plus lambda minus 6 is 0. So that means I'll be getting it as 3 and 2. So it will be the splitting the middle term. I'll be getting it as plus 3 and minus 2. So that gives us lambda is equal to minus 3 or lambda is equal to 2. Okay, so once we get both of these, right, what do we do is that we need to find the matrix that is P and the D. Okay, so the diagonal matrix that is there, D matrix is generally written as this way, which is lambda 1, 0, 0, lambda 2. Okay, it depends on what you take lambda 1 and lambda 2. Okay, so whatever you take lambda 1, the corresponding vector, eigenvector will be P1 and, sorry, V1. And whatever you take as lambda 2, the corresponding eigenvector will be V2. Okay, and then we place it in this way that will be V1, V2. Okay, why? Because we are taking lambda 1 first over here. Lambda 1 is first, and that follows V1. Okay, so it follows the same convention. Next. Okay, so for this D, I'm gonna just take it as minus 3, 0, 0, 2. So what do we get is mx is equal to lambda x, but this x is vector, that means it is x comma y. So instead of writing it this way, what I'm going to do is that I'll write it as xy equal to lambda times xy. Okay, so what was the that was the transition matrix or transformation matrix, that was this minus 4, 2, minus 3, minus 3. Okay, so that means minus 4, 2, minus 3, minus 3. I think I've written it right. Minus 3, 3. Okay, see. This is one of the mistake that even the students make. Xy will be equal to lambda times xy. So what do we do is that this x xy, sorry, in place of lambda, first we'll put in the lambda 1 value. Now it's up to us what we can take lambda 1. So in what I'm going to do is that I'm going to take lambda 1 as minus 3. So this will be minus 4, 2, minus 3, 3 times xy equal to minus 3 xy. Okay, so we are finding some connection between x and y from this. So if we do the matrix multiplication, we'll get it as minus 4x plus 2y in the first as the first value, and the other will be minus 3x plus 3y. This is equal to minus 3x minus 3y. All right. So in this, I always try to do both the equation just to cross check my answer. So if I look at the first one, it is minus 4x plus 2y is equal to minus 3x. So that means if I take this minus 4x on the other side, it will be 2y is equal to x. Correct. So from this, okay, we always try to get the eigenvector value to be integer values. Okay, so to get it as integer value, we can take randomly x and y values. Okay, we take a random x value and y will be derived from that. So if I take y is equal to 1, my x should be 2, y is 1, x is 2. Okay. Next, what I do is that just to cross check if I'm getting the same equation, I should get the same expression, same equation. Okay, from the second as well. So what do I do? Minus 3x plus 3y is equal to minus 3y. So what does that give us? That gives us 6y is equal to 3x. So that is 2y is equal to x. Done. So it's the same. So that means this answer is correct. Okay. Then the next one would be when I take lambda is equal to 2. When lambda is 2, I will get it as minus 4x. Sorry, no, 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 no. Minus 4, 2, minus 3, 3 times xy will be equal to 2 times xy. Okay, so that will give us minus 4x plus 2y is, and over here minus 3x plus 3y. Okay, this thing will be equal to 2x and 2y. Equate the first value, that is minus 4x plus 2y is equal to 2x. So that means 2y is equal to 6x, that is y is equal to 3x. Okay, so if I want to find the Eigen vector for this one, this will be the second one because that is my lambda 2. Okay, lambda 2 is 2. Yeah, so this will be what? X, I can take it as 1, y will be 3. So from this, okay. Oh, yeah, and again, cross check. Always cross check this. So it will be minus 3x plus 3y is equal to 2y. So that gives us y will be equal to 3x after simplification is the same thing. So that means the answer that we've got is correct. So from this, the diagonal matrix that we get, okay. So what I'm going to do is that I'm going to take my lambda 1 over here, lambda 1, 0, 0, lambda 2. So if I do that, my lambda 1 will be what? This will be, what was my lambda 1? I did, yeah, minus 3 and 2. So this will be minus 3, 2, 0, 0. Okay. And similarly, on the similar line, the p value. So with lambda 1, the corresponding eigenvector was 2 and 1. So this will be 2, 1, and the other one will be 1, 3. Okay. So in the question, if you go back to the question, it's written write down D and find P. Done. Okay. So this will be the final answer. There you go. The D value is this and P is this. Okay, that's it for today. Thank you. So what do we get is mx